Okay, example 77.1, we're supposed to solve the cube root of x cubed plus 6x squared minus 4. And notice the radical ends right there. The minus x and the minus 2 are not underneath the radical. And the first thing of radical equations that we learned before, and it still holds true today, is you want to isolate the radical. You want the radical expression by itself. Everything that's not the radical goes to the other side. So I'm just going to throw the x and the 2 over there. So I'm going to keep the cube root of x cubed plus 6x squared minus 4 over on the left-hand side. Keep it equals where it's at. And then I'm going to move the minus x over, becomes positive x, move the minus 2 over, becomes positive 2. So that's objective 1. Get the radical by itself on the one side. Everything that's not the radical goes on the other side. Next, I want to get rid of the radical. The whole purpose of isolation is if you take the radical to whatever the power that matches the index is, you will get the radical to disappear. So this is a cube root. So in order to get rid of the radical, I need to cube the radical. The requirement of algebra is if I do something to one side, I have to do the same thing to the other side. So cubing the left-hand side requires me to cube the right-hand side. Now, left-hand side, easy. If you take a radical with whatever index it has and raise it to the exact same root, all that happens is the radical disappears. So x cubed plus 6x squared minus 4. So again, that side's easy. The right-hand side, be careful, it is x plus 2 of binomials to the third power. That does not mean x cubed plus 8. It means x plus 2, which is being multiplied by x plus 2, which is being multiplied by x plus 2. If we just take a look at these two, x squared plus 4x plus 4, that's just my shortcut for squaring a binomial, right? We've already learned that. Take a binomial times itself, you square the first object, you double the product of the two objects, you square the second, or if you want to, you can FOIL it. X times x is x squared, 2x plus 2x makes 4x, 2 times 2 makes 4. That product is still being multiplied by x plus 2. So now I've got to multiply x plus 2 times x squared plus 4x plus 4. That means I've got to multiply x times all this stuff. Then I've got to multiply positive 2 times all this stuff. If I add like terms, I end up getting x cubed plus 6x squared plus 12x plus 8. So x plus 2 cubed is going to be this product down here. I would say that's a scratch sheet of paper for me. Okay, I'm going to do that on a scratch sheet of paper. So my paper itself looks like this. This is probably what's in the book. That's the first thing I write on my paper. I go ahead and move that stuff over because I can do that pretty easily, right? Then I show that I cube both sides. I cube this side on a scratch sheet of paper and transfer my work over, okay? Now, my job, once the radicals disappear, is simply solve for x. Now notice that this happens quite often. The exact same things on both sides. I'm allowed to subtract x cubed from both sides, and all of a sudden x cubed is gone. Similarly, 6x squared, positive 6x squared, positive 6x squared, cancel, cancel. If things on the left-hand side match things on the right-hand side, subtracting those things from both sides gets them off the equation, right? The remaining equation is pretty simple. Negative 4 plus 12x plus, or equals 12x plus 8. I'm just going to move the 8 over there. That gets me minus 12 on the left-hand side is equal to 12x on the right-hand side. Divide, we get x equals negative 1. Now with these radical equations, as always, that does not necessarily mean it's the right answer. That means of all the answers in all the world that could possibly be the right answer, that's the only one that's allowed to be it. Okay? And if it works, that's great. If it doesn't work, we throw it out and put the empty set. All right, so at this point I check by simply substituting negative 1 in place of all the x's in the original expression. So I've got the cube root of, all right, what's negative 1 cubed?
Negative 1.
What's 6 times negative 1 squared?
6.
Plus 6, right?
Yep.
Negative 1 squared is positive 1 times positive 6 makes positive 6. And then minus 4. Then it says minus x, that'll be minus minus 1, which is plus 1, minus 2 is supposed to equal 0. Alright, so just substituting negative 1 in for all the x's creates that expression. Altogether inside here, negative 1 plus 6 minus 4 is 1, right? Cube root of 1 plus 1 minus 2 is supposed to equal 0. Once you know it's true, you don't have to go any further. What's the cube root of 1? 1 plus 1 is 2, 2 minus 2 is 0. That's true, right? So you don't necessarily have to write it all down. Once you believe it, you're good enough. So that's the right answer, and we circle it and we move on. Again, if this came out and said something weird like, oh, 5 plus 1 minus 2 equals 0, which is absolutely false, strike that out and put in the empty set. All right, that can happen. It doesn't happen too often on those with cubics, but just so you know, it usually doesn't happen with the cubic ones. But if it did, throw it out, put it in the empty set.